Now let us do the same for an extended object. Here I have again drawn the full diagram, and on this side I will show you the step-by-step procedure to draw. So here I have my mirror. Very simple. Here I have my object. I am drawing it with a different color because these rays, you will get confused with the object and the rays. So the trick here is to take the corner of the object and do the same as we did for a point object. So I'm going to do the exact same thing, but I'm just going to do it for the corners of the object. So drop a perpendicular, the same, drop a perpendicular, and then show a ray of light. Now draw the normal. This will bounce back, and the normal, this will also bounce back at the same angle. Now we are going to extend the perpendicular, and we are going to extend backwards the reflected ray of that corner of the object. Now I'm going to do the same. I'm going to extend the perpendicular and extend this reflected ray backwards. Now I have these 2 points, and these 2 points, when I join them, this is the image. Now since I have not done this with proper measurement, I'm doing it on a board, so you might think that this is over here and this is over here, but it is correct. This is the method to do it. It looks fine over here, so this is the method. This is the object and this is the image. Now let us understand what is field of view. As the name suggests, it is the field in which the image will be visible to the eyes. Let us see how to draw this. Say I have a mirror over here, and this is my object. Now it is the region of the extreme. I'll just show you. So we will, at the corner of the mirrors, send 2 rays. As we know that from an object infinite light comes out. So over here I am taking these 2 lights which are going to the extreme ends of the mirror. Now I know that it is a plane mirror, so at the same perpendicular distance an image will be formed. So I'm going to draw that image over here. This is the image, and now I'm going to connect it over here. This is nothing but the reflected ray. Look, this got reflected like this, and similarly I'm going to connect this point to this point, and we are going to get the reflected ray of this incident ray. Now this whole region is the field of view. What does that mean? What it means is that suppose that you are standing in a room in which there is a mirror. Here is the mirror, and you are standing somewhere over here. Now there is a possibility that you either can see yourself or you cannot see yourself. Now you must have noticed that sometimes you are not right in front of the mirror, but you are somewhere over here maybe, but you will still be able to see your image in the mirror. That happens because you are standing in the field of view of the mirror. So suppose this is the mirror and this is an object. Let's say I place some object over here. Now if you stand over here, you will not be able to see that object. But if you stand over here, which means that your eyes are over here, then you will be able to see the mirror. You will be able to see the image of the object. That is the meaning of field of view, and this is how you draw its ray diagram. Now let me show you how to make it for an object which is not directly in front of the mirror. Let's say I have this mirror, this is the mirror, and the object is lying over here. Still, somewhere in the room you will be able to see this object through the mirror if you are in the field of view. So how do we draw? First step is to drop the rays of light at the extreme this is at the extreme corners of the mirror. Second, we know that perpendicularly there will be an image at the same distance, somewhere over here. Now I'm going to connect these two points together and extend these lines. These are nothing but the reflected rays of these incident rays. So the field of view is actually just the region between the extreme reflected rays. Now this becomes the field of view, which means that if you are standing over here, then you will not be able to look at the image of the object. But if you are standing somewhere over here, then you will be able to see the image of the object. Let us draw it for one last orientation. I'm going to place the object over here. Now you must have already understood what to do. Send incident rays on extreme ends. Make the image by yourself by drawing a perpendicular line at the same distance. You should try this one by yourself. Connect it with the extreme points of the mirror and extend it further. Now this has become my field of view. This whole portion. Now let us see the rotation of the mirror. Suppose that I have an object over here. So now there will be an incident ray coming out of the object on the surface of the mirror, and its reflected ray will bounce back. Now what happens if I keep the object fixed there and I just take this mirror and I tilt it at an angle of theta? What will then happen? Let's say I tilt it at some angle theta. What will happen is that the reflected ray will get tilted at 2 theta, which means that when it was plane horizontal and the object was kept over here, there was an incident light which came and it went like this. When I tilt this plane surface, when I tilt this mirror itself at an angle of theta, the reflected ray gets tilted by 2 theta. That's all. Now let us take a look at the minimum height of the mirror to see one's image. Let's say that this is you, your height is h, then of what size should the mirror be and at what height should it be placed so that you will be able to see your full image. Yes, you do not require a whole length mirror of the same height and size as you to see yourself. If the mirror is only of the half length of you, like if your height is h and if the height of the mirror is h by 2 and it is placed at h by 2 height from the ground, then you will be able to see your full image. One also important interesting point is that there is only you can say a vertical height um, constraint to this topic, that it has to be at h by 2 height and of h by 2 length. You can take the mirror all the way over here, but still if it is of h by 2 length and kept at h by 2 height, then you will be able to see your whole image. As you can see, I have also shown the lines here that the incident light from your head will go to this extreme part of the mirror and will bounce back to your eyes, and your foot's the light of your foot will go to the extreme end of this mirror and will reflect into your eyes, and you will be able to see your whole image. Now let us understand another interesting topic, that let's say that there is a wall here. There is a wall and it is of height h. Now you want to see the image of the full wall in a mirror. So where should the mirror be? Interestingly, if you take the mirror whose length will be one third of the length of the wall and which will be kept at a height one third the height of the wall, then you will be able to see the image of the whole wall. Yes, just like it was h by 2, h by 2 of seeing your full image, it is h by 3 and h by 3 for seeing the image of the full wall which you are standing in the in front of. And you should be in the middle, like the distance of your position should be right in the middle of the mirror and the wall. And this height is mandatory, but the length of the mirror h by 3 is the minimum. It can be more. You can take this much big mirror, this much big mirror. H by 3 is the minimum length of the mirror. Now let us understand the object and image velocity for plane mirrors. So this is very easy topic. Let's say that you are standing over here and this is a mirror. Now if you move here with the speed of, let's say you move with some speed v, then your image will also be visible to you moving with the speed v towards you, right? And if you are, this was in horizontal direction. Now if you move in vertical direction, then you will see that your image will also move with the same speed in the same direction. Now if you move over here with some angle, then your image will also move with the same speed, but it will extend the equal angle at the mirror. Say you move like this, and the vector representing your your velocity extends an angle theta at the mirror, then the vector representing the velocity of the image will also extend an angle theta from this side of the mirror at the mirror. Similarly, if you move like this, your image will move like this with the same speed.